Okay, so we're going to do this example together. Now, we're solving this problem here, so when we solve, we want to solve for x. We want to get x by itself. Now, I noticed in this problem that that we have squared terms here, and so that indicates to me that it's a quadratic. And if I'm solving for quadratics, I first want to set it equal to 0. So I'm going to rewrite the question right here. So negative 2x squared plus 4x plus 1, x squared minus 2x. So if I'm setting it equal to 0, I'm just going to go ahead and move these things to the other side. So I'm going to subtract x squared here, and then add 2x. There you go. So this side cancels out to 0, and then we get, so I'll just extend that over, we get negative 3x squared plus 6x plus 1 over here. Now we've got it in the form that we can find our a value, b, and c value, because it just lines up with ax squared plus bx plus c is equal to 0. So we're looking at the coefficients, which is just the number next to x. So this would be the coefficient of x squared, coefficient of x, and then the constant. So our a value is equal to negative 3, our b is equal to 6, and our c is equal to 1. So we're just going to go ahead and plug that in the quadratic formula, and just so you have it here, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go plug that in real quick. So we have x is equal to negative b, so negative 6 plus or minus the square root of b squared minus 4ac all over 2 times a. Now we're just going to go ahead and do some simplifying. So we'll have x is equal to negative 6 plus or minus the square root of 36 minus, minus times a minus is a positive, so you have plus 12, made that a little bit long, all over negative 6. Alright, so we just keep on simplifying, so we get x is equal to negative 6 plus or minus the square root of 48 all over negative 6. Now, some might think this is our final answer, but it's actually not, because what we need to do is we need to simplify the radical. We need to look for perfect squares that we can take out of there. So perfect squares are going to be anything that has, you can take the square root. So this would be 4, that's 2 squared, so 3 squared would be 9, 16, 25, etc. So we're just squaring numbers, so just 2 squared, 3 squared, 4 squared. Alright, so what I know is that that 16 is a factor of 48. So I'm going to simplify this. So the square root of 48 is the same thing as the square root of 16 times 3, because you have a property that allows you to do this with radicals, which is the same thing as the square root of 16 times the square root of 3, which is equal to, so the square root of 16 is 4, right? So that's just going to be equal to 4 square root of 3. So we're going to replace this with our radical over here. Okay, so just simplify the radicals. We get x is equal to negative 6 plus or minus 4 square root of 3 all over negative 6. Alright, and now we need to go and simplify this last part, and sometimes it makes it easier for people to see if you go and split them apart, but what we're looking at is, well, you can write it like this as well, just splitting apart the plus or minus would be negative 6 over negative 6 plus or minus 4 square root of 3 over negative 6. So that makes it kind of easy to see how you can simplify it. So that would be equal to 1 plus or minus, so then 4, 6 would simplify to 2 square root of 3 over negative 3. So this would be one way to write your solution, or an equivalent way would be to go back, looking back over here, we know we can take out, or they all have a 2 in them, so we can take out 2, so that leaves us with negative 3 plus or minus, and you can only simplify this part here, not the square root, this only the coefficient here. So plus or minus 2 squared root of 3 all over negative 3. So these are your two solutions, so negative 3 plus or minus. And these are the two acceptable ways of showing your answer. Alright, usually this one's better, but you can write it like this as well. It's equally correct. Alright?